page 187 in your textbook. So this part will teach you how to interpret distance time graph. So here have two examples of the graph for you to see. So one by one, we look at this one first. So this diagram show the motion from 0 to C, just like from KL to Miri. Example, the motion from 0 to C for a distance of S meter. How we know 0 to C? What is the distance? So the distance is S meter. This one is meter. This one is second. In period of T time, T second. Just like, okay, from, let's say you move from table of student O, go to table of student C. In the distance, let's say the distance maybe is 40 meter. And then the time maybe is 20 seconds. Example only. And then OA, look at OA. O go to A, have positive gradient. So for your information, recall back, straight line, if in this direction, you will have positive gradient. If in this direction, you will have negative gradient. If the straight line like this, you will have greater equals to 0. So what can we say at this graph? So OA, you will have positive gradient. And then this gradient is represent the speed of the motion from 0 to T1. And then motion at uniform speed, not changing. Uniform. If it move at 30, so from here to here, move at 30 meter per second. Example only. And then motion for the distance of S1 meter in a period of T second. They will say motion of the object, let's say this 10 meter in the period of 10 seconds. Example only. Can understand? So we go through one, later on have example. And then for AB here, horizontal, so you know actually is 0 gradient. And then the distance, no changing, meaning that that thing is stationary, stop, does not move. Okay, rest, or sometimes they say rest for a period of time. So does not move because the distance not changing from T1 to T2. After that, okay, so we can say stationary for a period of T2 minus T1 second. And then for BC, same like OA just now, positive gradient. And then motion continue until C. So OC, you can know motion of S meter in a period of T second. So all go to C, you have motion, have S meter, move in T second. Okay, so just overall go through only. Later on we look at example, you can understand better. And then for this example, actually this one OP and PQ is the same meaning, but the differences is like this. Okay, this one is motion from O go to R, pass through P and Q. So OP, I think OP and PQ we not see, we straight away see Q and R. You can understand better. Okay, QR, you have negative gradient. So negative gradient meaning that negative speed. So negative speed meaning that object move back to original place or move in opposite direction. So this one very important. If you have negative speed, meaning that move in opposite direction or the object move back to the original place. Okay. So now look at example. I think example you can understand better. Look at example 4 at page 187. So distance time graph, this one, show the motion of a car and a tour bus. So you need to know which one is car. So this one is car, this one is tour bus. So graph OA represent the motion of the car from Puchong to Melaka. And then graph BC represent the motion of the bus from Melaka to Puchong. So determine the differences in speed of two vehicles. So when they talk about speed, then you will think about the gradient. So gradient of bus and tour. So you just go to calculate the gradient. So simply choose any 2 points. So this one is 0, 0. And then this point is 2, 150. So simply 150 minus 0, divide 2 minus 0. The formula, not formula, the unit, actually no need right. No need right. For maths is okay, no need right. So final answer is 75 for car. Now we look at for bus. So this point is 0, 150. This point is 3, 0. So you can use 150 minus 0, 0 minus 3, or use the other way around. Key in getting negative 50. So negative 50 is the speed for the bus. So they ask you the differences of the speed. So negative only indicate different direction. They are moving in different direction. So you no need go to bother about the negative here. You just need to compare the speed, right? So speed for the bus actually is 50 kilometer per hour. So differences, just minus it. Big minus small. So differences is 25 kilometer per hour. So now, any question? Can understand so far? Can If you don't understand or you confuse some part, you can just raise up your hand or you on your mic and you stop me. It's okay. You ask me. Okay. And then example 5. Okay, distance time graph show the motion of a car for a period of 4.5 hours. So determine the duration when the car is stationary. So keywords here is stationary, meaning that when is the car stop. So rest. So 2 to 3, right? Hour. Hour number 2 until hour number 3 is stop. But they're asking duration. Duration meaning that how long the time is stop. So 3 minus 2 is 1 hour. Question second one, A2. Determine the speed of the car in the first hour. Okay, in the first hour is at here. So the speed of the car, meaning that need to find gradient for this straight line from 0 until here. So this point is 1, and then what number? But actually you don't have number here, don't know, right? So you can extend it. You can use this point. Okay, why can use this point? Because this one is a straight line, right? So straight line, gradient will be the same along this straight line. So you can straight away find gradient using this point. So go to find. If you know this point, you use this point to find. But now we don't know. We don't know. So we use this point. So calculate, getting 75. And then question B, describe the motion of the car for the last 90 minutes. So the last 90 minutes, you need to calculate at where last my 90 minutes. So this one is in terms of hour, right? 90 minutes meaning that 1.5 hour. 1.5 hour and not 1.5. Yeah, correct. 1.5 hour. So starting from 3 o'clock until 4.5. So need to describe the motion. So how to describe the motion? You can calculate the speed of this straight line. So go to calculate the speed. So this point is 4.5, 270, and then this point is 3,150. So go to calculate the speed. 270 minus 150, 4.5 minus 3. Getting speed is 80 km per hour. Then you describe like this. The car travel for 120 km. How we know 120 km? 270 minus 150. Traveling, the distance is 120 km. Okay, so 120 km with the speed 80 km per hour in the last 90 minutes. So this is how we explain. You can explain about the distance and also explain about the speed. So far okay? If okay, I continue example 6. This one you need a lot of examples so that you can understand better. Suhana cycled to post office to send Hari Raya greeting card to her close friend. So the distance time graph is this one. So determine total distance in km. So total distance, how you calculate? You see, yeah. So from here, go to post from her house. Go to post office. After that, you will notice that negative, right? Negative meaning that they return back. So this one is 2 km plus, this one is stop, right? And then plus another 2 km. So we have 4 km. This one is go, this one is back. So from here maybe is her house, go to post office, something like that. Okay, question A2. Find the value of t. Okay, where is t? If Suhana cycle with a speed of 8 km per hour. Okay, 8 km per hour. Go to post office. Find the value of t. So t at here. So talk about rate of change. So you need to calculate the distance. So distance 8 km per hour. So we'll calculate here first. This one. Time. Okay, distance. Oh, wait. Speed is 8 km per hour. So we can write down speed equals to 8 km per hour. So speed is distance divided by time. So distance, they're asking you, okay, distance is 2, right? So from here to here is 2. So 2 divided by the time that you want to know equals to 8. So cross multiply, you will have 0.25 hour. So 0.25 hour convert become minute. So actually is 15 minutes. So 15 minutes. So here because it's starting 9:20, right? So until here you need to know is 9:20 plus 15 minutes. So actually is 0.935. So this is how we find the value of t. And then question B. Describe her journey from post office back to her house. So how to describe? So we need to find back to her house, meaning that need to describe this part. So do like just now. Go to find the rate of change of the distance, meaning that go to find the speed. So at this point is what? This one is 1010 minus 0950. Need to convert become minute. Okay, need to convert become minute. And not become minute, become the hour. Sorry, because after minus you will get in terms of minute, right? Convert become hour. After that, this one distance is 0 minus 2. So simply take this point and this point. Or you convert become minute first, not minute, hour first. And then you go to key in and you get negative 6 kilometer per hour. Then this one, negative meaning that different direction. So actually the speed is 6 kilometer per hour. So you can say Suhana cycle for a distance of 2 km in 20 minutes with the speed of 6 kilometer per hour. So every time they say describe the journey, so what can you say is you go to find gradient, which is mean by the speed, and then you can say travel distance how long, in what is the time, within how many minutes or hour, and then with the speed of what. So this is how we describe. This part, make sure you understand properly, because later on you will have one assessment criteria D for this part. So motion with different speed. What happens if you have motion with different speed like this? So this one, they will ask you, in these cases, if the speed of motion usually change in the journey. So in this case, we will use average speed. So when you have average speed, meaning that total time divide, total distance divide total time. Okay, this formula need to memorize. Okay, Zabeda want to visit her friend in Muar. So the distance time graph show her journey from Segamat to Muar. So here is Segamat to Muar through Tangkat. So calculate the average speed from Segamat to Muar. So if they're asking you calculate speed of Segamat to Tangka, so just calculate the gradient for this. Because these cases they want Segamat to Muar, so meaning that average because it's different straight line, so different gradient. So go to calculate gradient average of this gradient. So meaning that total distance is at t divide total time is 1.5 hour. So key in, you will get this 53 1/3 kilometer per hour. So this one is average speed. And then question B, is the rate of change in distance of car from Segamat to Tangga. So now focus on Segamat to Tangga is 50 km per hour. Calculate the distance in km between Tangga and Muar. So need to calculate this as. So just use the formula of gradient. And not use formula gradient. This one I'll multiply straight away because they use the average speed at here. So rate of change at here is 50 km per hour. So calculate the distance. So using average speed multiply total time, getting 50 km. So the differences is at t minus 50. So getting 30. Can understand this one? Can understand? Okay, huh? So question C, describe the motion of the car from Segamat to Muar. So from Segamat to Muar. So how to describe? So the car moved for a distance of 80 km in 1.5 hour with average speed of the one you calculate just now. Just explain using the average speed. Okay, so 7.1b is your exercises. This one, I think I choose question 4 question. You answer question 3. Question 2. Wait, I see first. Average. Okay, 2, 3, 4. Number 1 on it. Okay. This one I will continue next lesson. If you have no question, then you will do the exercises. Huh? Any question?
No.
Okay, then see you again. Hey, wait. I want to take attendance first. I screenshot first. After that, you can go to do your exercises. Okay, done. Thank you, class. See you again. Bye.